Hello, everyone. Welcome for today's meetup. Nice to have all of you present today in this event, and my pleasure to be your presenter for the next time. So today our topic is from browser to board, embedded testing for web testers. I will present you a perspective from the point of view of web testing about embedded testing. In the end, everything is about test, but in this case, I'm trying to, let's say, reduce the distance, or let's say conceptual distance between embedded and web testing with this meetup. Welcome, everyone, and let's start. First of all, I will present myself. I'm Luis Dias. I'm from Portugal, and I studied electronic engineering and computer. I have 8 years of international experience, and currently I'm lead tester in Andersen lab company. I've worked in different industries like automotive, energy, health, and kitchen, in both sides of embedded testing and mobile and web testing. And then I'm working in Andersen for 3 years. So this is my profile. This is it's about myself, and now I will start presenting our meetup. So, the agenda for today, we will start speaking about the embedded testing concept. So, understand what is the concept, what is exactly embedded testing. Then we will move to the next point, how this embedded testing differs from web system. Here it's more about the high-level vision. Then, third point, it's about what they have in common. So, what is similar between one and other. Then, the fourth point, it's about key technical differences. Here, we will focus more technically in this part and compare some technical aspects from the two different types. Then, the testing types inside of each group, because imagine in the big concept, let's say, for example, embedded, we have different sub-levels of testing. And in the end, an overview and questions and answers part. So this meetup is for people without any kind of previous knowledge, and because of that, some concepts are presented in the simple way. Of course, they can be described technically deeply, but considering the audience, we will do it on this way. So, and let's start. Embedded testing concept. What is embedded system, let's say? When we are talking about embedded, we should understand two concepts, software and hardware. And they work together to cover one specific function. Then we have the embedded system. The software is designed and created to run in this specific hardware because this software will integrate the hardware and the systems. The software will be able to control some parts of the hardware and interact with the behavior through this hardware. Then it's possible to understand how the embedded systems are present in all the world. So they are completely everywhere. In our cell phone, computer, television, printer, smartwatch, and other devices that we can see, like medical devices, in a lot of areas. So basically, all of that devices have one thing in common. They have software that it's running inside, let's say, of specific hardware, and it will operate to cover one functionality or function. And this is the concept of embedded device. So now let's start presenting the differences between embedded systems and web systems. We will compare and we will have in the slides the differences and go for different points on each other. So, first of all, task scope. When we are talking about embedded device, generically speaking, they are designed for operate of a specific functionality. Look for this microwaves device. It's designed for a specific thing, cook the food. Of course, it's possible to add or remove some parameters about the time, about the temperature, etc. But the specific function is clear, objective, and that's it. Of course, there are more complex embedded systems that can be operated on different ways. But for other hand, we have some kind of website where it is designed for multiple actions and users. We can have different users, different actions that operate different things, different flows. So in terms of dynamic, is quite different from embedded. But in any case, there are some similarities on some parts. Then we have real-time context. So a lot of embedded systems are really, really important, the fact of a real-time response. For example, in this picture, we can see an embedded system integrated in the car that it's responsible to understand the behavior around the car. What it represents? It represents a critical safety system because we have people operating and interacting with the cars. Imagine the system fails or takes a delay. Imagine the car is going on the street and one person passes in front of the car. If the system don't react so fast, we can have critical consequences on this context. From the other hand, when we are talking about web and mobile, the number of critical situations are lower compared with embedded systems in general. So this is one difference, this real-time context and real-time answer needed. Then we have the failures impact. As I referred in the previous slide, imagine one failure in autonomous driving that can cause a big accident, can kill a lot of people, can have very, very high and critical consequences. For the other hand, we also have some particular situations in web and mobile context, but that are not so critical in a lot of times. For example, if I fail the login, okay, the user will not be so happy, but at least no one will die. Something like that. This is the point that I would like to introduce to you on this slide and compare the context in terms of failures impact. Again, the example of the website and microwaves, but in this case about user interface. Normally in embedded systems, it's little and simple or no user interface or something so simple through hardware or something like that. By other hand, in web and mobile, user interface, and also we can have the topic of user experience, are two parts really, really important to, let's say, guarantee the success of the product. Because the interaction of the user is so high, the user like to have a good experience, like to have a good interface to operate and be intuitive, operate with the product. In embedded also should be intuitive, but the interface is, let's say, less complex, at least in average, than the web and mobile devices. So now let's have a look on some common aspects between embedded and web. First of all, we have the interfaces, and we can compare it to big systems. On the left side, we can see an embedded device where we have on the left, we have one camera here and another sensor of position here, and a camera here. That devices will give input to our system. That it's a board where we have a microcontroller that will process the data and act in the environment with this sound device, with these lights, with this screen, wherever. And we have these interfaces. Okay, we have some sensors, some devices that collect information from the behavior, interacting with the main device and acting in the actuators. And we have all of that interfaces between these parts. In parallel, when we are talking about web, we can see here the parallel between this structure in embedded and this structure in web. We can see here the browser where the user uses to communicate and then interact with the other parts through APIs, etc., web services and databases, and all of that interfaces and connections also should be validated and have a parallel comparison with the device in embedded part. Then we have the core software. So in embedded, we use a lot the term firmware, that it's not more, not less than software dedicated to running a specific hardware. Here we have different devices. As you can see, I put here this diagram to help understand better the difference and understand better the category. So we have the software, that it's the big umbrella, let's say, and then we have the firmware for embedded and mobile and desktop software, normally called only software. For other hand, when we are talking about web, we have here the division between front end and back end, and we have, of course, different technologies, different technical stack. We will see it later. But here we can have a comparison and understand that, okay, we have the firmware in embedded side, and we have the front end and back end and the interaction between these parts on the website. Then we have the initialization. Both systems have initialization process. In terms of embedded, the initialization is done using bootloader, startup routine, start configuration, setting up some parts, some parameters of the hardware, etc. For other hand, we have the web. When we have, for example, loading some application, we have the initial page load, we have the app initialization, some startup activities, etc. So they have the same, let's say, concept for initialization, but small, let's say, differences and initialization processes itself. Then, in both situations, are really used the state machines in embedded and also on web. Of course, I use it here, simple case, just to allow you understand and be more clear how the state machine works. Basically, we have here three different stages where we have the LED off, LED on, and the LED blinking. And here in the arrows, we have the actions that switch the stage. For example, if the LED is blinking and the button is pressed, then the LED will turn off. And then, using these state machines, we can manipulate and understand the full system behavior. A lot of times in embedded projects, the state machines are reflected in the code and the way that the system is programmed. It's possible to create, let's say, a state machine of the system, and according to the state and the actions, it switch between different behaviors and activities. We have a similar thing in the web, where we have, for example, land the home page, view the product, view images, read documents. So there are some kind of state machines where you can switch from different stages and we can do some actions. For example, imagine I'm in the home page and I click in the products, I will go to the view product page. As a bridge in embedded, the link is blinking, I press the button and the LED is turning off. And through this way, we have here, let's say, some similar things between embedded and web. Then another part is about the performance. So both systems are care about the performance and how it works. The speed and execution is really important in both of them. And we can see here on the left side, referred to embedded, we can see interrupt latency, task execution time, cycle account, etc., etc. So we can see here different threads. Threads are tasks that are running in our device. And to reach the real-time reaction of the system is really important to control these times and interruptions and etc. in the system. On the same hand, we have here on the right side the latency, response time, requests, and page load time. All of that parameters are presented here in this picture, where we run some performance analysis, let's say, and we can see here all that parameters with values and understand the times and check if the performance of our system is good or not. Here it's quite similar between the two sides. So in the web, we need, let's say, to have it quickly and have good responses and fast. Also in embedded, the same logic. So the logic here is exactly the same. Then we spoke about performance, but now we have about resources usage. So basically, In embedded, the resources usage is really, really important, and manage the resources. It's important to keep our memory clean, the performance of our system, etc., and keep the resources in the best performance usage. So for that, we should control, for example, CPU load, power consumption, stack and heap usage, memory power, whatever. So we have some parameters that can be controlled on the same way that we have it in the web and mobile. When we have CPU usage, database load, bandwidth, etc. And we have here, let's say, screenshot on the right side where we can check the times and some analysis of these resources usage. So again, we have the same principle, the same concept, but of course with different parameters that are specific for each system, but the logic is exactly the same between the two parts. Then we have the communication protocols. Of course, when we are talking about embedded and web, communication is common, is needed to communicate. Embedded systems communicate in one way, and other systems communicate in another way. It's like people in the world. Some people communicate in Portuguese, another people in Spanish, another people in English, another people in other languages. Here is exactly the same. In embedded, we communicate with some protocols, low-level protocols, low-level because we are operating really close to the hardware, and we can talk about CAN protocol, I2C, SPI, UART, and others. For other hand, when we are talking about web, we can have some examples like HTTP, HTTPS, REST, WebSockets, etc. But that are protocols. Protocol is not more, not less than amount of rules to communicate. How will we communicate? And this principle is exactly the same in both systems, in web and embedded. The difference is the protocol itself. So, summarizing, both systems using protocols to communicate. Protocols are the rules to communicate. For example, here we have a CAN frame. This is a frame of CAN protocol of embedded, and the CAN protocol says, okay, the first part is for SOF, the second part is for identifier, the third part is for RTR. And this is the CAN protocol logic. For the same hand, we have here in web, HTTP, HTTPS, where we have, for example, the first line about URL, the second line about the body, and the third line with other parameters. So, and here we can do a bridge between the two parts and understand that they have very, very similar cases on this way. Another thing that it's very useful and common between web and embedded is the error handling. So this is a critical point in all systems because error handling helps us understand quickly and fast why our system is failing. We have some predefined error handling codes in web. You can see here, for example, starting for is a client error where we have, for example, not found, not acceptable, bad request, etc. For other hand, we have starting by 5, that 5xx or 500, whatever, that represents server errors. And we have others. We have 100, 2, etc., 200 success, whatever. So this is the error handling codes. By the same way, we have error codes embedded. In some projects, they are predefined, okay, but in a lot of projects, they are defined in the requirements phase. So the client, the customer, or the team defines, okay, this code 999 will represent that. And we have a map with this description and the codes as we have in web and mobile. In embedded, it's more, let's say, personalized, the error codes, but of course they are aligned with the requirements, and they are specified for the system itself. Of course, in web, we have some, let's say, standard in general, because the requests are done on some ways, but in embedded, it don't works like this. For example, error handling can be the door is open. But if I don't have one door in my system, this error handling don't make sense. So it's adapted to our device and to our product. But in the end, The concept is the same. Error handling, we have codes that represents errors. And then we have documentation that allow us understand what this error is meaning for me. And of course, facilitate the debug and understand the failures, etc., etc. So moving for the next point, we have the recovery. Both systems are completely open for failures. And both systems, web and embedded, have recovery processes. So, like a reset, like a restart, we'll see later about that. But in the overview, it's about this recover mechanisms like reset and safe mode. And you can see here some screenshots about startup settings. If you want to recover the old version of your software, if you want to recover some specific part, whatever, on the same way that we have on web. Then we talk about security. Is one of the most important topics when we speak about systems in general, web and the embedded itself. And we have some mechanisms for that. We have, for example, the CRC or redundancy for embedded systems. And we also have OAuth, JWT, role-based access control, and other security with logins, etc., two-factors authentication, and other ways. We have these kind of systems here. And we have here one example on the left side about embedded. Imagine the receiver will send a message to the sender. The message is sent, but is using some kind of key to do some operation in the value. This key is reused in the receiver to do the same operation and understand if the result is the same. If imagine that the key is multiplied by 2. I send 4, I multiply by 2 in the sender, and I have 8. I send 4, I multiply by 2 in the receiver, and I have 8. Okay, 8, 8, it's okay. It's secure. Something like that, very, very high level explained, of course. Then about the environment, where it will run, where will be our system. As I explained previously, our embedded system will run in some, let's say, hard circumstances. For example, under the rain, with high temperatures, in some vehicles with high speed, with vibration environments, humidity, electricity environment, so a lot of them in the space, in the water. So it makes our system mandatory to be completely tested in terms of not only software performance, but also in the hardware performance to avoid being destroyed or affect the behavior of the system from external reasons. Then in web and mobile, we have our system product, whatever, running in different web browsers. So, and here we have the parallel. We have different web browsers and Android, iOS, and in embedded, we have these environments. Of course, some embedded devices run using Android, like infotainment, etc. But here it's more to do a bridge and understand the concept of the two environments where it will run, well, where it will be applicable. Our embedded device will be in this kind of environments. Our web application will be in this kind of environment with browsers, computers, mobile phones, tablets, etc., etc. And here I have a summary about the two parts. So we have here what is tested on each side, and here some notes about what I presented to you previously. So about embedded testing and web testing. Then in the next slide, we will see the key technical differences. So first, where it's running. Software itself runs in our board. It's something like this. It can have different models, different appearances, depending on the project, on the product, etc. But it's something like this. And our applications will run in the servers. About operating systems, we have mainly big part of the embedded products are Linux-based and RTOS real-time operating system, and the other parts related with web and mobile, we have Linux and the Windows Basic. Okay. About the program languages in embedded, we are using very low-level languages because we are more close to the hardware. It means that we are more talking about C, C++, C Sharp, Python, Dart, in the very, very low level assembly, where we work really close to the bit level, so really, really low level. On the other hand, web and mobile, we use another high level languages like JavaScript, Python, Java, SQL, and others. But they have some similarity between the different languages. And for example, some of them are common. Imagine C Sharp, it's used also in embedded and also in some web and mobile projects. So here we can understand how they can differ and how similar they are in terms of languages. Communication protocols here from a technical point of view, and with these pictures and diagrams explanation, it's possible to see here, imagine this is a CAN bus, this is a CAN communication inside the car. Look that we have the motor, transmission, instrumental panel, power steering, etc., etc. And in these lines that are physical lines, okay, we have two cables that are connecting all that devices, and the communication is done through CAN protocol. Each device of that has what ECU, that is some kind of microcontroller, let's say, that communicate with others using CAN protocol. Here on this side, we can see example and web applications where we have the different devices that are communicating with the server and then request something to the database and communicate here. This slide is more focused to present to you how the communication is done and how it's possible to understand better technically the diagrams between embedded and web devices. Traffic sniffers, it's a concept more close to web and mobile because we use a lot of them like Charles, Fiddler, Wireshark, it's here. They are used as proxy to collect our traffic. But it can be also used in our embedded devices. It's CANoe. It's a tool used to check CAN messages. Of course, there are a lot of other functionalities, but we can use this tool to do exactly the same thing that we do with Charles and Fiddler. Basically, it will work as a proxy and we will go to the traffic and understand what messages are shared, what the message structure, speed, whatever. So it's possible to validate all of that things exactly on the same way as we do with Charles and Fiddler. So now let's talk about testing types. Here I created a big picture about testing types, the main testing types, of course. There are more, but I select the most famous, let's say, to include in our presentation. We have hardware in the loop. What is this concept? When we have the real hardware under test. I have my product, my hardware, and it's running here. Software in the loop, it's more about software itself. We are testing the software. We have the software running in some virtualized environment or something like that. Real-time testing and performance. And for web, we have UX, API, load stress testing, and security testing. So also the most famous that we know. Here we have the hardware in the loop. We can see here that are test benches where we have the hardware. Imagine here embedded device from the car, and we test it using the real device that we will have in our project and in our car. Here it's an infotainment device, and we have here some peripherals that are simulating the devices around the car. Then we have software in the loop. For example, using Android Studio. Here, look, previously we had this infotainment device here where we test the screen and the screen itself. Here we are emulating this device and using Android Studio, we are clicking with the mouse in the computer and testing something with this device in the computer, not with the real hardware. First case, hardware in the loop. Second case, software in the loop. Then we have the real-time testing where we have the communications. Look, this is Canoe tool again. It's from Vector. And here we can check a lot of communications ways with CAN. You can see examples here. For example, interrupt must be handled within 5 milliseconds. Motor control loops run every 10 milliseconds. All of that things can be validated using this tool, Canoe tool, that will analyze CAN communication in the car. Then also in Canoe tool, it's possible to test the performance of our system. You can see here some graphs where we see the speed, we can see some data changing, some values, message structure, threads, etc., etc. So, and you can see here some examples. So, imagine to measure how long the task takes to execute. Imagine that I have a task that is using a lot of time of my system, a lot of time of execution. So I can try to rework this task or do it in another way, another approach to turn the system faster and quickly. Then we spoke until now about embedded, so hardware in the loop, software in the loop, real-time testing, performance testing, and now let's do the bridge with web. Why UX? So I guess big part of you knows what is that. Basically, the interface of the application where you click the buttons, test some flows, test some things, user logs in and submits the form, shopping chart, checkout flow. So this kind of validation. We have here a bridge with the virtualization in embedded devices, where we virtualize or put that in our, let's say, in virtual environment. Here, it's about web, also some similarity with embedded. Then we have the API testing on the same way that we had it here with Vector tool. We have the Postman, for example, where we call APIs and where we can check the response. We can validate the code. We can validate the content of the response. If we have the parameters, if the parameter match the expectations that we request, etc. So also validation of that. But in web, we have API testing. In embedded, let's call it on a simple way, CAN testing. Of course, it's not the correct technical term, but to be helpful to understand the bridge, API testing to test API, CAN testing to test CAN protocol and communication. So this is the way and the comparison between the two parts. From other side, we have the load and stress testing. So here I have a screenshot from Gmeter tool. And practical examples simulate 1,000 users accessing the website simultaneously, or API response time under stress, etc. So it's exactly similar to the things that we do in our embedded devices. So we don't test with 1,000 users accessing, because normally it's accessible for 1-2 users or not a lot of more, but test some stress, for example, under hard situations, under vibration locations, under high temperature, and we can simulate a lot of different situations for embedded devices. And then we have the security testing. You can see here the SQL injection testing, authentication authorization check. We have here the example of SQL injection where someone send a request and change the URL and put student ID or 1 = 1 to make this condition be true and access some part or something not authorized in our system, and then receive the data, in this case, data from all students from the application. Then I'm sharing here with you a comparison overview where we have different test levels, where we can have, let's say, a bridge. Okay, as I told you, the goal of our presentation today is not go deeply technically in the both concepts, web and embedded, but it's reduce the distance between the web testers and embedded testers, let's say, trying to show to web testers and mobile that embedded testing is not something so far, is not something so out, or something that it's really, really different from web testing. Of course, there are big differences, but conceptually it's possible to understand a bridge between each other and understand that they are more similar than we expect. So now I will present to you an overview where we have two scenarios. So on the first scenario, we have a web system where we have a web browser and web server. The web browser do a request, HTTP, can be GET, POST, whatever, using the HTTPS protocol, and receive a HTML JSON response, and it's processed here and it's going. We have traffic sniffers like shards, fiddler, wireshark, and in the same way, in the second part, we have embedded, where we have one ECU in the car. ECU, remember, is this microcontroller in some specific part. We have different ECUs in the car. Using CAN messages, communicate with other ECUs in the car, and it sends a CAN message to the ECU in the car. Instead of HTML or JSON, it uses some data space in the CAN frame, some data space specific to send this data. And with this picture, this is one concrete example with a big picture about embedded and web. Here, final overview. So development environment, we can see here some technical description, programming languages used, low level and high level, debugging tools, GTAG, logic analyzers, browser and dev tools, some testing frameworks for embedded and web, simulation and emulation, we use simulators, hardware in the loop systems, etc. And web systems, we use mock stubs and test environments. Traffic sniffers, we already had a look about Canoe in this presentation, and fiddler and shards. Automation level in embed is more limited and complex. In web is high and well integrated. CI/CD integration, partially because of hardware dependency. Embedded systems are really dependent from the hardware in the end. And normally in web systems, we can get full CI/CD support. Of course, just to finish, hardware dependency in embedded test systems is required, and web systems no. So consider this, I finished my presentation, and I can open now the space for questions. Please feel free to put your questions. Let me see, we received some of them in our chat. Give me just a second to get it. Okay. So someone asking about what is the prior experience for programming or QA for both sides? So based on experience to start being a tester, web or embedded, we have some generic experience about QA, okay, some mindset generic for that. And then each system has a specific particularity. So I guess the first thing is have this generic experience. And answering the second part of the question about the programming skills, it's not mandatory programming skills to work with embedded or web, but it's a really good, nice to have, because in embedded systems, we also have sometimes tests to validate the interface or test to validate some things that are manual and you don't need to program anything. But it's a very, very high plus to have these programming languages skills. Of course, you can start for simple testing and slowly from manual things to allow you to understand better the concepts and the logic, and start after that phase, start in programming languages and automation side. So I guess we don't have more questions. So rest to me say you thanks a lot for your presence today. Thanks a lot for your interest in the topic. Feel free to contact me if you have any question later. And please use the rest of the time to leave your feedback about our meetup. And thank you all for your participation one more time. Thank you.